This is a question, October 1743 variant, question number 7. Combination of two topics, Newton's law and work power energy. First part is said, least force, find it. And I discussed many times, there are two kinds of concept. One is, he said, least force, okay? If it's a least force, I'm writing least force. Of here, for example, the least, or here just largest, just for knowledge. Least force means it is about to move down. Make sure about to move down, about to move down. And largest force means about to move up, about to move up. And when about to move down, so friction is upwards. When about to move upward, so friction downwards. So very, very important. So keep in mind at least and a maximum minimum concept. So let's start. First of all, mass 0.2 he given. So naturally I can say here, this is 2 Newton's weight. And is that this is coming R component, you know, it is always perpendicular to the surface, 90 degree with the surface. And this is coming 2 cos 30. And is that a weight component is parallel acting downward, 100% confirmed to sine 30. So sine 30 is, if you write a number, is equal to 1. How come? You can type in calculator, sine 30 is a half it. So I can write 1 Newton also to save our time. Anyway, so ST has a 2 components, one parallel to surface. You can see, I repeat again, one parallel to surface and one perpendicular to surface. Okay, and 15 is given here. So this is coming T cos 15. This become T sine 15. Okay. Now, according to situation, he said that least force, so about to move up, sorry, about to move down, about to move down. I read a word about to move down. So naturally, friction will be backwards this way. And first of all, I think this idea is clear. But you know, there's a 2 component. This component of the force is sportive to R, sportive. It means these 2 forces acting upward, this downwards. So if I ask you what is the R, so say, sir, R plus T sine 15 and equals to 2 cos 30. 2 cos 30. I repeat, this force and this force both acting upward and this acting downwards. Okay, so I will bring this on the other side, and R value I'm getting easily. And cos 30 is root 3 by 2. I repeat again, you can type in calculator. I save my time. If I multiply into 2, so this is only root 3. I can say root 3 minus T sine 15. Okay, so this is R value. And what is F friction formula? F is equal to mu R. And mu is given by him, as you can see, that coefficient of friction, look at the mention, coefficient of friction of surface 0.3. So I'm writing 0.3. So I'm finding it now here. So this story is very clear, and I'm bringing it down now here. Okay, fine. So let's start. So F value is mu R, which is 0.3, and R value in the bracket, I am writing on the top, from the top, root 3 minus T sine 15. So alhamdulillahi rabbil alameen. To save it, okay, I can multiply also inside, but let's move on next. Situation, this is a perpendicular components I have deal. So these 2 plus equal to that. Now let's talk about parallel to surface. So I will start from here or start from there, no problem at all. Net force equal to MA. But he said about to move, if you read the question carefully, least force to make rest. What does rest mean? Acceleration confirms 0. So I can start from here or from there, no issue at all. Okay, let's start from up. So T cos 15, sportive force is friction plus friction, and this is against. You write 2 sine 30 or you write 1. So same thing. I'm writing -1 equal to 0. Now T cos 15 and friction value come from here. So I'm writing what here? 0.3, and 0.3 can multiply inside, student, like this. So I'm writing here 0.3 times 2 root 3 and negative T times 2, 0.3 times 2 sine 15. And this one I bring on the other side. This one I bring on the other side. So let me recheck. So 0.3, this I got it here, and 0.3 into this, I got it here. There are 2 T's, you can see, 2 T's, right? T common out. When I take T common out, student, algebra, basic algebra, this part and this part, I will write in a bracket. So this negative sign, make sure of the sign. I think clear. Now this value I will bring on the other side of the, okay, when I bring other side, 1 minus 0.3 into root 3. Now I will write just one step and I think you can understand what is going to finish now. So this is 15 minus 0.3 and sine 15. And let me type in calculator, it will give me answer. So hold on, please. Let me type it in calculator. Be careful because a small mistake can lead us to go wrong answer. Root 3 and in denominator, so cos 15, cos, and make sure in degree mode, okay? So cos 15 and minus 0.3 times to sine 15. And answer is coming with us 0.540. Let me write here. 0.540803. But I don't want. So Alhamdulillah Rabbil Alameen, we have done it, our job. Alhamdulillah Rabbil Alameen. So first part, student, is over. And let's go for the part number 2. So I believe first part is clear. Yes, student, part number 2, I'm starting now. He said that tension T force is now removed. It means this force, no more there. No more there means T gone. All components gone. Okay. Now he said that a new force of 0.2 Newton acting on P. It means particle is there. Particle is there. Let's say I make a particle, a big particle here, this P particle. Okay. And he said that a new force acting 0.25 Newton. But where acting up? Acting up the plane and parallel to the slope. Okay, acting up. It means it is acting up and parallel to surface. And I believe all people understanding why I make it here 0.25 Newton force acting upwards. Okay, fine. He said that starting from rest from P, it means let's say this point is P. Okay, and the starting means at this position's velocity is 0. Okay, fine. After moving a distance of 3 meters, so let's say it moved here, it reached something here, and S is a 3 meters, okay? So it passes through A point. So let's say this point is A, and I'm labeling P on the up here, P. So P point is starting from here. You know, it is very clear. Okay, you see, diagram make question easy. So as a teacher, as just you, Newton law, work, power, energy, even whole mechanics, please make diagram. Let's move on next. He said P passes through point A. So it's passing through here, and this is our speed to find out. So velocity at A is our task, and velocity at a P particle is given 0. I think all student understanding up till now. And particle is moving downwards, that is for sure. Okay. And if I make this kind of triangle, you see this kind of triangle, you can see clearly this triangle. And this triangle, I can make it below separate. So just for having the height. And there's a 30 degree and 90 degree, and there's a 3 meters, and there's a height. I think all students understanding why I'm finding height, because to apply magic formula. So opposite by hypotenuse, you know it very well, is called sine 30. And sine 30 is a half. So I got a 3 multiplies there. I got 1.5 or 3 by 2, same thing. Okay. So it means this height, student, I can tell you this 1.5 for sure. Okay. Let's apply the magic formula. What is the magic formula? You know it, work done by applied force, work done by frictional force, kinetic energy plus potential energy at the end point A, and K plus starting point P. Hold on. Let's apply one by one formulas. Okay, let's start. First of all, this I will consider as a ground level A. So height at the particle is A is taken as a 0. So potential energy at A level is 0. That is for sure. Okay. And potential energy at a P, I can find mgh. Mass is 0.2. G is 10. Height, I just got 1.5. So when I multiply this do by 10, this is coming to 3 joules. I repeat, let me check. By 10 is cancelled. 2 into 1.3 is a 3 joules, correct. So power, potential energy at a P is 3 joules. So let's talk about a kinetic energy at this is 0, because it's starting from the rest from here. So kinetic energy at a P is 0. Kinetic energy at a particle, I can find half into mv square. V is unknown. So I got it 0.1 velocity a square. I believe this is clear. Now I hope so up till here you understood. But problem is only one here. What about this force? And where is work done by friction force? These two components we have decided. This right hand side, all values are decided. Only thing is that left hand side values, we have to work on it. So let's talk about the first of all, one by one. I will talk about, hold on students, hold on. These are dragged below. And now I talk about work done by friction force. Friction force into distance. Common sense distance is 3 meters. Friction force is very interesting to know. And that, we have done before even, but now there's no inclined plane. So F is equals to mu R. Mu is 0.3. And particle is this acting upward R and acting downwards called 2 cos 30. Okay. And cos 30 is root 3 by 2. So it's root 3 by 2. It is mean, what I'm finding here. If I type in calculator, so cos 30 roots, it's become root 3. You can check it. So root 3 is R value. So alhamdulillah rabbil alameen, friction force is coming 0.3 into root 3. You can check in calculator even. So I can find it easily, but problem is only one. Particles going downward, friction is acting backwards. This is a friction force. And this force 0.25 will behave as a friction force as well. How come, sir? You can ask me. Because this force is sportive to friction force. I repeat my words. Listen to me. As this particle is coming down due to weight, due to its weight, it is dragging downwards. So there's applied force is 0. Applied force 0 reason. Can you find any applied force acting? But you can say, sir, this applied force acting, but hold on. This applied force acting is against a motion. It's not with motion, against a motion. Okay. Or you can do one thing. If you deal this as applied force, then you have to write negative sign. Why negative sign, student? Because against the motion. So I will use in a friction component. So let me count this value and this value together. So I will deal 0.25, hold on, 0.25, yes, 0.25 and plus 0.3 root 3 into distance 3 meters. This will give me work done by friction force. And work done by applied force, I will deal as a 0. Why, sir? Because applied force parallel to motion, nothing given. This applied force is actually trying to stop the particle. For example, the particle is dragging downward. Just imagine, I tell you, the motion, and this man is trying to stop it. He's pulling backward, but still he's failed to pull it downwards, pull it upward, but still particle is moving downwards. So this force will behave as a frictional force, like against the motion. So it will add in friction. So these both forces, I will add them together. Or I think you got a point. Now I'm going to type in calculator. This values, wait a minute, students, 0.25 plus 0.3 times 2 root 3. I got it. And this answer times 2, 3 meters. And I got it, what here? Work done by friction force 2.3088. I think now I'm going to solve it finally. This is coming from here. Let's start 2.3088. This is sorry. This is a work done by friction forces here. Sorry for that. Okay, this is 0. This is why 0? Because I said that. Okay, kinetic energy at A is what? I'm plugging this value here, 0.1 VA squared. And potential energy at A is what here? At 0. Why 0? Because I consider this as a ground level. And kinetic energy as P is 0, you know it very well because starting from rest. And negative into positive, negative. And that I got a potential energy is 3 joules. So I think clear. And now student 3 will come on this side, 3 minus 2.3088. And this 0.1 will divide like this. And VA left and take a root of the whole thing. It will give our answer. So let me type in calculator parallel with you. Inshallah, I believe you'll understand. Let me check. Root 3 minus 2.3088 and divided by what? 0.1. And my answer is coming with me 2.629. Hold on, let me write. 6.2. Say sorry. Please let me check again. 2.62908 or 09. I don't want. Velocity at A is 2.63 meter per second. Alhamdulillah Rabbil Alameen. I believe the point is very clear and it's a little bit complicated question, but we have done it well. Alhamdulillah Rabbil Alameen.